So let's use a case where you have some mechanism, we don't know what it is, that you're going to detect tampering within a system. You got a microprocessor, you have some non-volatile memory, and you have some volatile memory. And so you're going to load your program and your operating system on that microprocessor, and it's going to start executing its program, and then somebody's going to tamper with the system. In a purely software case, what you would do is you would take that tamper and you say, I was tampered at this time, and this is how I was tampered with, and you would take that and you write a little log file and you'd stick it in Flash. Right? Well, from the hardware reverse engineer's perspective, they don't care. Because what they did was they copied your complete Flash file before they started the attack. And all they're going to do is as soon as they see you write that log file, they're going to wipe the whole system out, put back in the original file, and move along with their day. But now they learned something about your system. They learned when you detect something. So they learned about your particular defense mechanism. Right? They learned that when I do this, he writes a log here. That means something. And if you think about that, you can iterate that over time. And so the exploiter really gets to understand your system. To marry those two, what you would probably do is you would deterministically set something within the hardware. You'd want to make a modification to the hardware itself, such that within that's tied to that log file, such that the next time you start it up, if that log file wasn't there, you could now completely you could put the microprocessor into a severe halt, which essentially never allow it to reboot again. So essentially you've taken an extreme reaction to that case, but because you know that they're tampering. And so we look at things, so if you had a pure software guy, they would never look or even think to look at the microprocessor itself and see a fuse get blown within the microprocessor. The hardware person is really going to, that's all they look at. They look and see where there's fuses and they say, well, these fuses must do something. And so they're very different disciplines. So if you can walk across those, then it's very good. Does that make sense at all?
Yeah, that helps.
Okay.
Any other questions?
Quick question. Scott, from a Raytheon perspective and working in the research realm, what do you see are weaknesses of students who are fresh hires into the company? Are there any areas that you think that academia is not doing a good job at preparing students?
You know, probably one of the things that does happen and causes a very high dropout rate, so I think it's partly our problem, but it's kind of necessitated by the business, is that when you come into an effort, particularly a large company, there's already lots of things going on. That's why the company's there, that's why it exists, and you got to kind of find a way to become part of that quickly. And in doing so, you might work on something that is not so overarching. You're not going to be leading the whole effort right from the beginning. And so I think there's an expectations issue with things. I think there's general knowledge of business practices and how businesses are run and what they do. That's really not a technology question. I think the people coming out of school, technically speaking, are very capable. I think it's all those ancillary things that help you kind of, I wouldn't fit in a company is the wrong term. Really exploit, leverage, and take advantage of the things that are available to you. And I think a lot of students come into a large company and feel a little bit lost, and that there should be more hand-holding and assistance. And my guess is the company will never provide enough of that. And so at the same time, I would hope there would kind of be the expectation and a knowledge of how these big business practices work and what happens that would be healthy. Make sense?
Mm-hmm. Assimilation.
And that's what I didn't want to suggest, assimilation, but yeah, because I think once, at least I tend to mentor a lot of young people within our company just because it's something I enjoy doing. And so when new people come in, I generally make a relationship with them, and then I'll just constantly contact them and say, how are things going? What are you doing? And I find usually once they've kind of gotten over the hump, there's some hump when you initially come into a company where you feel completely lost at what's going on, and all the things that are happening seem to make no sense whatsoever. And after a couple of years, there's an understanding of what's happening. And but generally, those things are not unique to the company you just landed in. They're generally just standard processes, practices, and procedures that if people were more aware of and more understanding of, they'd probably feel more comfortable and would be more productive quicker. Yeah.
Just wondering, you mentioned that detectives always win. In that case, what kind of detector are you referencing? There's a lot of levels of detector.
Turn on your microphone.
If you consider top level of the detector, he will always try to do the detector. You don't consider your level different application, different company with different applications. They require maybe different.
And I don't know how much, and that, actually this would be a good answer to your question. Exposure to what is actually happening, to the extent you can do that within the academic environment would be very helpful. And not to just, I don't know if everybody can hear the question, but essentially if we use the standard model of 3 levels of attacker, or 1, 2, and 3, where the lowest is kind of the person in their garage, the second level attacker is somebody who's somewhat organized, they kind of know what they're doing, but they're at home and their intent maybe is to shame somebody or get a little money. And then level 3, where you got a nation state concerted effort, somebody can put resources behind it and take a lot of time. Well, why wasn't I concerned about those level 2s and level 1s? And my answer to that is kind of a scary one, and I hope you understand that it's kind of purposely scary, is that what we see right now, nothing else matters. Level 3 attackers, nation state attackers are everywhere. And they're all over us. And so if you're worried about the 2s and the 1s are getting crowded out of kind of this attack market today. People are very sophisticated in the level of attack, and now I'm talking about both reverse engineering of hardware on systems, but also on the internet we know, or the net we know is the internet. And including those nets that have been secluded and taken off of the internet, even those have issues with them. So that level 3, that nation state threat, and so, you know, if you can guard against the nation state threat, then you've easily defeated level 2 and level 1. But they just don't show up on our radar, so to speak, anymore.
That's a good place to end right there.
Okay.
Thank you.
So, you know, it's impossible to, it is impossible to, the antivirus task is impossible, you know.
Oh, antivirus is, yeah, completely
There's a-
useful.